This is a video that covers some of the material you need to know for the first 3 lab projects that involve taping. You may be using taping at other times, but the first 3 will be fairly intensive use of tapes. So I'll be covering some of the general material that you need to know about it so that we don't spend a lot of time in the class talking about it. And also, because this will be the beginning of your labs, to also talk about some of the general procedures, and some of these other labs will also have some further discussion on general procedures as we discuss new and different instrumentation. But in this particular one, I just want to start at the beginning, so to speak. So, first of all, I want to say that there is a demonstration of some of the taping techniques that I want you to use in a longer video that's available about the same time that this video is posted. So you definitely want to make sure you look at that for the actual details, because I have work that was done in the field. I was demonstrating to a class on campus, both in the classroom as well as in the field. So because this is also the video that is the first video that will be used to help you get your labs done properly and correctly, I want to start by talking about some of the things that you need to do. When you come to class, you'll be given a locker. You'll be assigned a locker after we break you up into teams. And we'll talk about teams here in a second. So you want to first begin by looking at everything in the locker and inventorying everything. This will in effect be a checklist. So you want to have this properly organized so you can easily check off that everything that's supposed to be there is there, so that you can report to your lab instructors if there's an issue, if something's damaged, something is missing, and so forth. Learn the proper names of the parts. We will go through all of these parts in the locker, even the things that you will not be using, but learn them. Pay some attention to them. Don't just call this the stick and that the pole and so on and so forth. Use the correct names for them. So this list that you create, you'll be turning in a report with every lab that you do, every project that you do. And one of the things you'll be doing in your first project is also turning in this inventory of your locker. So you'll be wanting to make a copy of it at some point. When you do this, you will notice that there's a tall, when you look at the lockers, that there's a tall cabinet and then a shorter cabinet and then 2 drawers underneath the cabinet. And it's really easy to forget about the 2 drawers. So make sure you inventory what's in the drawers. And remember that the equipment, the safety, the making sure nothing is broken, nothing is lost, nothing is damaged is the joint responsibility of the team. And anything that happens, unless somebody wants to fess up, will be levied, whether that's a fine, point deductions, or repair costs will be assigned jointly, unless somebody wants to take full responsibility for it. If you lose something or if you break something, you need to report it. You don't just put it away in the locker and lock the locker, turn in your key, and hope nobody notices. That's like a really bad thing. And the final thing I want to mention is that each of your lockers has a key tag, and that tag may or may not be unique, but make sure you remember for the day what that color is. You might actually want to write it down in your field notes. Why? Because students are very well known for losing their keys. And this way you know what color to look for as you go out and scour the field, because you will have to turn that key in. So we will be breaking the class up into units of 2s and 3s, just depending on the number of people there. So you might have 3 people on your team, or you might have 2 people on your team. We'll take an inventory of who has any experience at all. We'll look at several factors to decide how to put your teams together. We'll try to keep the teams together pretty much as they are, unless somebody reports a real issue at the end of the first set of labs. because we want to make sure that you grow in cohesiveness through the term. This is a really important part of learning how to work with others, or as they say in kindergarten, how to play with others. And this is a really important part of what you're learning in this course, and actually will be one of the factors that's used to grade you in a subjective way by your instructors. Keep in mind that when you have a team that is supposed to execute a project, you can't have all leaders and you can't have all followers. But you can have all collaborators. So it's really important that you get used to talking with each other, figuring things out, instead of running off half-cocked and starting something just because somebody thinks they understand it. Everybody else thinks they understand it differently, but keep their mouth shut. And then it turns out when they're finished with the project that they've done it wrong because somebody had a misimpression of what they were supposed to do, and the other two, even though they knew, kept their mouth shut. Becoming collaborative, to be able to do it without yelling at each other, to be able to actually talk to each other when the lab is finished, to be able to talk to each other professionally, are all things that you need to be learning in this class, and I expect you to be demonstrating improvement in all those areas. Some of you will be better than others, and so you may decide that somebody is a natural leader. The thing I must warn you against is if you have someone on your team who has experience, to simply slack off and let them do all the work. Number one, they could have learned bad habits. Number two, that means you won't be learning what you should be learning by having the field laboratory, and there will be a time when you will each be tested individually on skills you should have picked up in the field laboratory, and if you've been letting someone else do it, then it can cost you something. As I already mentioned, running off into the field half-cocked is not a great idea, so make sure that you spend some time planning the work before you go out, making some decisions on who's doing what. And once you get out in the field, you may discover that you need to revise things. And that's fine, but you get together, figure things out, and move on. And of course, as part of your laboratory work, you will have to write a lab report. I'll talk about this more at the end. But in the lab report, you will have to report on your activities. A lab report will have to be turned in a week after you complete your lab. So make sure that you are doing that as you go from lab to lab. And keep in mind that if you have 2 lab projects on a certain day, then you will have 2 lab projects to turn in, not just 1 for the day. All right. So for each lab, each project, each segment, because some of these projects may last a very, very long time, and you may actually decide to switch things up or have different people do different things. And that's why I say for each lab, meaning the entire lab, or a project within the lab, or a segment, figure out, first of all, who's doing what, and make sure that you all understand. That's by simply talking out loud. Yes, I'll be at the head of the tape. Yes, I'll be at the rear of the tape. Yes, I will be recording all the field notes, and so forth. And then figure out who's the nominal leader or person who tracks what you are doing and making sure it's what's to be done. This could be the head tape person, but it can also be the note taker if you have a 3-person team, because when you have a note taker, the note taker can get the responsibility for thinking things through, because the other 2 people are heavily involved in just getting things moved around and into position and so forth. The 3-person teams and 2-person teams are different dynamics, and you may see that if we have a mixture of those. We will do everything we can to avoid 4-person teams, because very often the 4th person has almost nothing to do. And what we have found is that 2-person teams where the communication is good are often much more efficient than 3-person teams, much less distractions, they're much more focused because they know they have less manpower to get things done, and so they tend to prepare better, do the work more efficiently, and so forth. So you'll have 3 different lab projects, possibly on 3 different days, But the first is called, I'm calling it Distance Project 1, and what you will do is you'll have a large nail or spike. First thing you're going to do is get some flagging, if there's not already some on it. Fold it over a couple of times and then push the spike through the flagging so that when the spike is pressed in flush with the ground, you have a little splash of color around the head of the nail to help you find it. But also pick a colored flag, and you want to pick what the flag is for the day that you're going to be using. Doesn't really matter what you pick as long as it's not the same color that more than 50% of the teams are using. So pick a color flag and stick it in the ground next to it so you can easily walk up to it. Then step off at least 75 paces. That means each step. So let me talk about what a step is. Let me just demonstrate that to you. So this is one step. That is 2 steps. Okay? Some people sometimes count 2 steps as a pace. Some people count 2 paces as a stride. There are different meanings. So when I say step, I literally mean 1 foot in front of the other. The next foot goes up in front, then it's the second step. So step off at least 75 paces. It can be a lot more. You can be as adventurous as you want. Go 75 paces at least, and then set another spike. Now if you're a really short person, you may want to go 80 or 85 steps. If you're a really tall person, you may be able to get away with a little bit less. But I suggest doing about 75. Certainly can be more than 75, and set another spike and make sure you have an extra flag with you so you can set the extra flag at the other end of the line. The thing that I want you to do is to be safe. You will all be wearing safety vests. We won't make you wear hard hats unless you start getting into areas where hard hats are significantly important, but we want you to stay in the grassy area for these initial projects. So stay within the field area that you'll be shown, and then once that's done, once you have the 2 once you have the 2 spikes in the ground, then each person in the team will step off the distance from one end to the other, and you'll do that 4 times. And then average the number of steps you took. So that needs to be done by each of the 4 persons. So that's the first phase of that. Then what you will do is you'll pull out your 100-foot tape. The rear tape person will stand by one of the spikes holding the tape in its handle. The front tape person then walks out towards the other flag, and you must have your chaining pins with you. You stretch the tape taut, and then you lay it on the ground after making sure that no loops that can create a kink are present, because when you stretch it taut, if there's a kink, you're going to break the tape or at least put a kink in it. So pull the tape taut and place a chaining pin in the ground. The chaining pin, by the way, should go in at an angle, so you don't place it straight, vertical. Always place it at an angle. Why? Because eventually you'll be using a plumb bob, and you want to make sure your plumb bob can hang right over the place on the ground where the chaining pin enters the ground. Now, let's say you measured 200 feet. Then your final segment may only be 13 feet and change. So there'll be a final segment where you only pull the tape forward just 13 feet so that the head tape person can measure the fractional number of feet, while the rear tape person holds a full foot mark on the tape, on the last chaining pin. So the only things you really need are your tape on the handle. You might want a taping handle if you want to. I'll talk about some substitutes for it. And chaining pins, of course, to mark your intermediate points so you know where your 100 feet are. Now you do this once, and the typical pattern is as you're advancing, the rear tape person pulls up the chaining pins. And if you look at your chaining pins, you will notice that there are 11 in the set. And that's to allow you to get 1,000 feet measured if you're going end to end to end to end until the rear tape person has to walk forward and meet the front tape person in the middle and hand them their 10 chaining pins so that they can tape another 1,000 feet. This would obviously for very long distances. Now, I've talked about how you do this. The tape is laying on the ground. Now, what you do then is in the field or in the classroom, depending on how comfortable you are with doing your math, calculate the average length of your pace to the nearest tenth of a foot. You'll be expected to remember this number because you may be asked this number at any time during the term, and of course each of you will perform this calculation. Then for distance project 2, so this is a separate project, a different lab if you will, go back into the field with all your gear for taping except the plumb bob. First you repeat the measurement you did in taping project 1, so you haven't pulled up the spikes. You first repeat the measurement you did with the tape in distance project 1, and then you do it again. So this would be the second measurement of that distance, and this would be the third measurement of that distance. And then what you do is you look at all three and see if they all match up within a quarter foot of each other. So you look at the maximum difference between them and see if they all match up within a quarter foot of each other. If not, you keep taping until you have 3 consecutive measurements that are all within a quarter foot of each other. Then you can average it. And then you calculate precision. And talk about this here in a minute. And this aspect of the project is called measuring with a fully supported tape along a slope with uncontrolled tension, meaning you're pulling on the tape kind of arbitrarily. So let's talk about how you calculate precision. So let's say your measurements are 213.64 to 13.88. That barely makes the cut because they need to be within a quarter foot of each other. You see 8.9 would be the very extreme. And then let's say you have another one which is 213.55. All right, now the 213.55 is a problem because it's too far away from 213.88. It's 33 hundredths away and you're only allowed 0.25. So you probably have to throw this last one away or not. You don't know at this point. So what you do is you keep measuring. And let's say the next one is 213.72. And you do another one and it's 213.64 again. Incredible, but that's possible that could happen. And then 213.79. So what you do there is, first of all, you average these three, and then you look at these differences. So your biggest difference is between 7.2 and 7.9, or between 6.4 and 7.9. Well, obviously it's the second one, and it's 15 hundredths of a foot, 0.15. So you take this average, whatever that happens to be. Well, maybe I should just go ahead and do the math. And what I will do, because they're all 213s, I'll just use the fractional parts. So I'm going to do 0.72, whoops, 0.72, and then 0.64, and then 0.79, and then I divide by 3. And I get, I'm going to round that to 0.72. So the average here is 213.72. And then I have this 0.15, which is the maximum difference between all of them. Now, it's more correct to actually look at the maximum difference from the average. So here we have 0.07, here we have 0.08, and here we actually exactly match up. So our biggest difference is 0.08. So what we do is we take the 0.08, divide it by the average, which is 213.72, and this comes out to be to this very small number, 0.0004. Well, that doesn't mean a whole lot. So what we do is we invert it. So on many calculators, you have a function that looks like this. It's 1 over x. I'm going to press that, and I get 2,672 if I was rounding out. And so what we do is we convert this to a fraction. It becomes 1 over 2672. Now, if this sounds like Greek, you might want to go back and look at your textbook. But this is the precision calculation, because in this course, we will start out anyway calculating precision this way, where basically we're saying that when we measured an average distance of 213.72 feet, we had an error of 0.08. And that translates into 1 foot of error in 2,672 feet. Now, when you divide the 0.08 by the 213.72, you get a very small number. So typically what we do is, because we know we're going to invert it anyway, even though the fraction looks like this, 0.08 divided by 213.72, we usually do the math this way. We say, aha, we're looking for what the denominator should be if the numerator is 1. So what we do is we put the 213.72 in first, and we divide by the 0.08, and you see we get the same number, 2672, rounding it off. And actually, when surveyors do this kind of calculation, they might round this off to 2700, because the last 2 significant digits, maybe even the last 3 significant digits, are probably not very important. So anyway, that's the first phase of Distance Project 2. Then in Distance Project 3, what we will do is do 3 measurements again, just like we did in phase 1. But the difference here is we take the tension handle, that should be 1 because each of you will only have 1 per team. You'll use a tension of 15 pounds that you will apply, and you'll discover that this takes some practice, because as you are both pulling on the ends and one person is trying to keep 15 pounds, you will discover that there is some dynamics involved, and you'll have to develop some good communication skills to be able to have a stable, correct measurement. The important thing is to be able to talk to each other, understand what's happening, and to get it done. And again, though, you do it 3 times. Also, at each end of the line, where the spike is, so if I have the spike at my feet and I'm looking at the other spike, what I do is I take a step back, and then I place a pole, and these poles vary from about 5 or 6 feet in height to much taller. But I would place this as close as I can vertically right on that line connecting the 2 spikes. And you would tend to do this at both ends. So you will have some poles that you will be given. Each of your lockers has what we call a prism pole, and you would place these in the ground and press them into the ground so that they're standing self-supported. So you have these poles at each end of the ground, so that's the additional equipment, poles at the end of the ground and tension handles. And now when you make every measurement, so if I'm the rear tape person and I'm holding the rear end of the tape, what I do is I look at the pole in the distance, and I look at where the head tape person is holding the tape on the ground, and I'll say, you need to move that way a little bit, or you need to move that way a little bit. Don't signal like this, because nobody can tell from 100 feet away which direction you mean. So always be very explicit. You can use your head if you decide ahead of time what you're going to use as your signaling method, but you also want to make sure that there's no wiggle waggle in the tape. And of course, you want to make sure there's no loops that can cause kinks or breaks. And you apply the tension and you repeat this same process, and so you're getting 3 measurements done using the tension handles and being very careful to align the tape with the line along which you are supposed to be measuring. And this time, all 3 measurements must be within 1/1500ths of a foot of each other. So it's no longer a 1/4 foot. We've decreased the constraint on how much variation you can have. We made it 1/1500ths of a foot. And again, if you don't have this, repeat until you get 3 consecutive measurements that do match up. And you calculate precision again the same way. One of the things you'll want to do is take this precision number and compare and contrast it to the precision you got in the previous method. And so what I say is, for this one, call it something like, and it doesn't have to be exactly this, but I'm calling it fully supported. It's still doing slope taping, but with control tension and alignment. And then finally, using the hand levels, determine at what height the front and rear tape persons should hold the tape so that each end is horizontal. You use plumb bobs at each end or one end, depending on whether you can hold one end on the ground, and you continue using the taping handles and the prism poles. So what you have now is this situation, or well, when you have this situation, it could be the ground looks like this, and you have a plumb bob at each end. Or it could be a situation like this, where the ground goes like that, and so you can actually hold the tape on the ground at one end, but you have to use a plumb bob at the other end. In both cases, it's still considered to be end supported. So what we're doing is, with each of these steps, adding a little bit more and more of the complexity, the hand-eye coordination, your fine motor skills and so forth, to see if you can fully engage all these various aspects into the taping. And you'll check to see that the 3 measurements done this time are within 2/10ths of a foot of each other. So I'm giving you a little bit more latitude than with the previous one. Why? Because when you're using the plumb bobs, when you are low skilled, when you're first starting out, you will have greater variation in the measurements. And again, you will calculate precision. And this time I'm calling it fully supported taping, control tension, alignment, and end supported. So that would be that aspect of things. Now, essentially here we've completed 2 laboratory projects. So there are 2 different lab reports that are required. I will summarize more of this in written communication to you, but you basically do a lab report for each one, and these are individual. So each student in the team submits their own lab report. They will have, for example, an excerpt, a photocopy or a scan of their field book pages as part of it. You will write down there the task to be accomplished and obvious things like date, the equipment that you used, who did what the weather and field conditions were. You'll, of course, show the data collected. A lot of that can be referred to simply by pointing out that it's in such and such a place in your field book pages, but sometimes you may have to laid out on the paper for analysis of some kind, and you have to show me how you did the analysis, how you figured out what the average was, what the average pace was in the case of the paces and so forth, and some kind of a discussion about what you found out from doing this project. And every project should also end with, how could you have done this better? How could you have done this better? And please don't come back with something like, oh, it would have been so much easier if I had used an electronic distance meter. What I mean is more like, we could have planned this better. We could have had better communication. We could have done this, we could have done that, and so forth. So that's kind of the introduction to those first two projects that you'll be doing. Now let me talk a little bit about taping. And as I said, I already have a longer field demo about this, but there's one thing I neglected to point out. So let me just show you something. When you are taping, I talked about using a tension handle that you add to one end of the tape, or you can have a leather thong that's attached here that you wrap around your hand and so forth. There is a way to hold the tape without causing it to break or develop a kink, and that's to have a smooth curve in the tape. And so if the other person at the end is placing a large amount of tension on the tape, you can keep the tape from slipping through your fingers if the tape is resting against your forefingers here, and then you use your thumb to also clamp on it. So now you're not using your thumb and forefinger to hold the tape the way some people might be tempted to hold the tape to resist tension. What you're doing is you're using all the friction that you can get by having the tape pass over your fingers. So I wanted to stress that's a valid way. That way you don't have to carry your taping handles with you. You'll still have to use your tension handles, because I expect you to use tension handles when the ultimate in precision is required. But this way you can have very good control. Even on wet days and days where there's some ice, you may have trouble with your fingers freezing up and getting numb and all that kind of stuff. But as long as you can wipe off your fingers to make sure that the obvious moisture is all gone, then you will be able to use a whole lot of apply a whole lot of tension, because there's so much friction between the tape surface and your five fingers. The other thing I just wanted to go over just a little bit, this device, a lot of them have this opposite diagonal quarters colored in red, because it used to serve as a target. It's kind of gone out of practice. It's called a gammon reel. I personally don't like them, and I don't use them anymore, but we happen to have them. But I'm going to ignore it for the most part. The thing I wanted to mention is that when you are taping, you've got several things going on. You're applying tension, first of all. You're trying to keep things from moving, so you can't be moving back and forth along the line, right? You're trying to keep the plumb bob stable, and you're either trying to mark where the end of this tape falls, or you are the rear tape person and you're trying to hold that 100-foot end, or some full-foot end if it's less than 100 feet, exactly on that mark. So a lot of the things you need to do is be very stable, make sure you're facing the tape, facing forward towards the front or rear tape person, depending on which end you're at, is not a good way. You always want to be where you're able to resist the pull on the tape. And then the other thing I wanted to point out then is when you are doing this, that when the tape starts swinging, the first thing, well, first of all, before you even hold the tape up, you should have pulled out your hand level and figured out, yes, I'm going to hold the tape at my chest height, you're going to hold the tape at knee height. I'm going to hold it at waist height, you're going to hold it at knee height. You can hold it on the ground, and I can hold it knee height, or I can hold it halfway up my shins, and so on and so forth. And sometimes you may have to pass the hand level to the other person, because sometimes it's easier to judge the relative heights at which you should hold the tape. It's easier to judge from one end than the other. But the important thing is, once you've decided all that and you have it approximately figured out, That's when you get yourself in position, make sure that you're actually able to pull on the tape without damaging the tape or yourself, and to actually get the job done. And the other thing, as I said before, is you always do this. You get the tape, the plumb bob, very close to the ground, so the tip is barely touching the ground. If there's a few blades of grass, they might actually help to damp out the swings. And then you keep repeating this over and over again. And keep in mind, you're doing that, you're watching the tension handle if you're the front tape person, so you got a lot of stuff going on. Take some practice, and then once you have it, then this is where you kind of relax the tension slightly on the plumb bob string, and then you let go of the tape, and then you walk down here, down the string, grab the plumb bob and either push it into the ground if it's soft ground, or make a scratch mark that's a V shape, and the V should point at the line that you're taping. It should be at right angles to the line. And so with those, we will now close this video.